Hello there. Really quickly, I want to show you how to solve a symmetric polynomial. Now, this is a quartic. It's symmetric in that we have the x to the fourth plus x cubed. On the other side, we have x plus 1, a sort of mirror image, even though they're different degrees. And then we've got a quadratic term right in the middle here. Now, there's a special technique we can use, and that's what I'm going to outline in this video. So the first thing I'm going to do is start by dividing everything by x squared. We can observe that x equals 0 is not a solution here. So when I'm dividing by x squared, I'm not going to be creating any undefined terms from the resulting equation. So everything gets divided by x squared. X to the fourth divided by x squared would be x squared. Now, while I'm doing that, I'm also going to rearrange it. I got 1 over x squared. I'm going to put the x squared terms together. So the x squared and the 1 over x squared. All right, and then I'll put, this will cancel. I'll just put the minus 4 here. And then I'm going to put plus x cubed divided by x squared will give me x. And then x over x squared will give me 1 over x. Now, this will create a special relationship where I can use substitution. I'm going to use u as my substituting variable and set that equal to x plus 1 over x. Now, why would I do that? Well, x plus 1 over x. If I wanted to suppose what u squared was, because I notice this looks like it could be close to u squared. It's not going to be exactly u squared, but it's going to be close. That would be x plus 1 over x. Okay, and we've got u squared, or that should be squared. There you go. We get x squared plus 1 over x squared, and then 2 of this times that. So x times 1 over x. Again, x does not equal 0, so this is okay. That'd be 1 times the quantity of 2, and we get this. So we get something very close to this. So if I split this negative 4 up here into plus 2, well, what subtracted from 2 would give me negative 4, so I don't change my polynomial. I get negative 6. Okay, so I've got right here, in this term right here, I've got u squared. So I'll rewrite this to be u squared, and then I'll write plus my u minus 6 equals 0. So I'm going to go ahead and transfer this to a fresh page. I've got u squared plus u minus 6, pardon me, minus 6 equals 0. Now, the whole purpose of this technique was we got it down to a quadratic that we can then solve. So I'll go ahead and set up diamond math, put negative 6 on top, I'll put 1 down below. I'm going to go ahead and my factors would be 3 and negative 2. So u plus 3 and then u minus 2 is equal to 0. And so when we set these up, we'll get u equal to negative 3 and u equal to positive 2. Very, very nice. However, these answers are answers to this quadratic right here. They're not answers to our original polynomial. So let's recall that u is equal to x plus 1 over x. Ooh. So let's go ahead and get this. Let's go ahead and sub them in one at a time. I'll start with negative 3. So I'm going to go ahead and multiply everything by x. Okay, so I get negative 3x equals x squared plus 1, and then I'll go ahead and add 3 to the other side, and I'll rearrange everything. So plus 3x plus 1 equals 0. Now, what we can do here is work through using the quadratic formula. So negative 3 plus or minus the square root of 3 squared minus 4 times 1 all over 2 times 1. Well, there's not a lot of simplifying here to do. There's negative 3 plus or minus 3 squared is 9, minus 4 is 5. That's a radical we can't simplify. And so that gives us 2 of our solutions. Now let's go ahead and do 2 on the other side. So I've got 2 is equal to x plus 1 over x. And I'll do the same thing I did before. I'll just start from scratch and multiply everything by x. So I get 2x equals x squared plus 1. Now I'll go ahead, rearrange and subtract 2x to the other side. Minus 2x plus 1 equals 0. And I've got, notice I got a perfect square here. So I got x minus 1 squared equals 0. Well, that just means x minus 1 equals 0. So x equals 1 will have a multiplicity of 2, and my other solution was x equals negative 3 plus or minus square root of 5 over 2. Look to use this approach when you have a symmetric polynomial. Thanks for watching.